This question is a 1 mark question from complex variable. Given integral of z minus 3 divided by z square plus 2z plus 5 dz, where this particular function you can take it as a f of z. So we have to find the integral of the function f of z. So given the curve is mod z plus 1 minus I is equal to 2. So we can take this as, if I take z as xy, x plus iy plus 1 minus I is equal to 2. So it is x plus 1 into I into y minus 1 is equal to 2. So it is a circle x plus 1 whole square plus y minus 1 whole square is equal to 4. Here the center is minus 1 comma 1 and the radius is 2. So now we can write it as minus 1 comma 1, the point is here, minus 1 comma 1, the point is here, and the radius is 2. So here it extends up to minus 3, and here it extends up to 1. Here it will extend to, if I take it as I, this will extend to 3i, and here it will be minus I. So this is a circle. This can be considered as a circle. Now we have to see whether the given denominator, which is a z square plus 2z plus 5, the poles of this particular z falls inside this particular circle or not. If it does not fall inside this particular circle, then the value of integration f of z is equal to 0. But if the poles fall inside this particular circle, then the value of integration is not equal to 0. So then what we have to do is we have to see the poles that are present inside this particular function. The poles are z minus 3, z plus I, z plus 1 minus 2i into z plus 1 plus 2i. So the points are minus 1 plus 2i, z is equal to minus 1 plus 2i, and the other point is z is equal to minus 1 minus 2i. So we have to see whether these particular points fall inside the circle or not. So now the point minus 1 plus 2i is well inside the circle, whereas the point minus 1 minus 2i is outside the circle. So because this particular value is outside the circle, this does not vary the integration from 0. Because it falls inside the circle, then this value is going to be not equal to 0. Now we have to write the part of the function as f of z, where the function does not have poles inside the curve. This can be written as z minus 3 by z plus I plus 2i and z plus I minus 2i. So this is a pole which causes a finite value or a value which is not equal to 0 to the particular function. So now the Cauchy integral formula says integral f of z by z minus a is equal to 2 pi I into f of a. Now because the value of z is equal to I minus 1 plus 2i, so now my function 2 pi I into f of, we have to substitute it with z with minus 1 plus 2i everywhere. So if we substitute the value of z with minus 1 plus 2i multiplied with 2 pi I, it will be 2 pi I into minus 1 plus 2i minus 3 divided by minus 1 plus 2i plus I plus 2i. If you see the value of this one, it will be equal to pi minus 2 plus I. Pi minus 2 plus I. So this value is present in option C. So the answer is option C.